Today we continue working with transformations and vertex form of quadratic equations. Our goal is to convert from vertex form, y equals a times x minus h squared plus k, which is our vertex form, into standard form, which is our most simplified version of this trinomial, ax squared plus bx plus c. We're missing an x right here. And to do that, we're going to use our polynomial operations to multiply and to combine like terms. So we're going to work through an example here first. We have steps 1, 2, and 3. We're missing a 3 here. And then we're going to fill in the general steps down here on our notes so that we know how to do this for the future. We have this x plus 2 trapped in this parentheses. We can't simplify it, so let's think in terms of our order of operations. We have parentheses, exponents, then multiply and divide, then add and subtract. So there's nothing to do with parentheses because we can't simplify x plus 2. The next thing is there's two things trying to apply to this x plus 2. We have this 3, which is trying to multiply, and this 2, which is an exponent. So between those two, the exponent wins. We need to deal with it first. And we learned in polynomial operations how to deal with x plus 2 squared. And to do that, we can either, if we've learned the shortcut for perfect square trinomials, we can expand it with that. If not, then it's very important that we rewrite it as x plus 2 times x plus 2 so that we don't miss the two middle terms. That is the most common mistake that we make in algebra. So now we can use either distribution or we can use the area model in order to multiply these. So using distribution, we would distribute the x to both of these. We get x squared plus 2x. Then we go back and distribute the 2. We get plus 2x plus 4. Using the area model, we'd get the same thing, just organized into our nice little boxes. So we have x plus 2 times x plus 2. We get x squared, 2x, 2x, and 4. And either way, the result after this first step is that we expand this into x squared plus 4x plus 4. And that takes the place of the x plus 2 squared. So rewriting it at step 2, we have y equals negative 3. And then our x plus 2 squared has now become x squared plus 4x plus 4. And then the minus 5 is still the same. So we have we've taken care of that. So we can use, I wrote kind of all this stuff off to the side. You could write it on these lines, but the idea is either we use distributing like I did on the left or the area model like we did on the right in order to come up with this perfect square trinomial. Next, we need to distribute the negative 3. So we're going to distribute the negative 3 to all three of these terms. I'll write that over here. So we distribute 1, 2, 3 things. That's going to get rid of the parentheses, and we'll be left with negative 3x squared minus 12x minus 12 minus 5. And then the final step is to combine our like terms. We ended up with two constants, one that was from k and one that came out of this perfect square trinomial. So we get as a final standard form answer, negative 3x squared minus 12x, and then negative 12 minus 5 gives us negative 17. So to summarize the process there's basically 3 steps. Number 1 is we're going to use distribution or the area model. Distribute or area model in order to square the, square that thing, the binomial. So we're going to square the binomial, which we write out as blank times blank, so that we don't forget the middle terms. Then we combine like terms. So that step was done over here where we had 2x and 2x, and we combined those into 4x. Next, we distribute the a term. So that's our vertical stretch factor. Remember that a that lives out here is going to be the same a here, and we distribute it to that trinomial. And then last, we combine the constants. So those are the 3 steps. I'll do a few of the examples here, but really this is not new material. This is just applying what we've already done with polynomial operations in the form of a quadratic equation. So 3 steps here. First, we're going to distribute x minus 6 times x minus 6. So we get x squared. We get 2 minus 6x's, so we get minus 12x. And then we get negative 6 times negative 6 is plus 36. Then we have this minus 27. Notice that step 2 is not necessary here because our coefficient in front of the parentheses was a 1, so there's no need to distribute that. Once we distribute the exponent by squaring the binomial, we don't have any multiplier left to distribute. So this one, we skip straight from step 1 to 3, and we combine our constants, x squared minus 12x, and then we have 36 minus 27 is plus 9. So you'll see that on the first 3, there is a coefficient of 1, a equals 1, meaning step 2 doesn't need to happen. The fourth one over here, though, has a negative 1, so that one is important. So we're going to have the negative. We're going to do x plus 3 times x plus 3. That gives us x squared plus 2 3x's, so 6x, plus 3 times 3 is 9. And then this minus 3. But notice that I needed to keep the parentheses here because the negative is now going to distribute to all of those. So when there's a 1 outside the parentheses, we don't need the parentheses anymore, but a negative 1 outside the parentheses has to get distributed. And I lost my y equals here, so let me write that. We've got y equals, then we have negative x squared minus 6x minus 9 minus 3, and then our final answer would be negative x squared minus 6x minus 12. So that's how we do those. Let's do one that has an a value that's not equal to a integer. So the next one's good. We have a 1/2 right here. So we're going to do 1/2, then we'll do x minus 2 squared, so x minus 2 times x minus 2. That gives us x squared. We get minus 2x twice, which gives us minus 4x, and then negative 2 times negative 2 is plus 4. We still need parentheses because this 1/2 needs to distribute, and then we have a minus 4 over here. So this is just all about following order of operations. In fact, I'm going to go back up to the notes real quick, and we're going to put this is exponent, this is multiply, and this is add. So we're just following down the hierarchy of PEMDAS. We're going P, no P, we do E, then M, then A. So we just go E, M, A down the tree. Okay, so to finish this one, we distribute the 1/2 next because that's the multiplication. So we get 1/2 x squared minus 2x plus 2, and then the minus 4 is unchanged. Our final answer, y equals 1/2 x squared minus 2x, and now we have plus 2 minus 4 is a total of minus 2. We'll do one more to wrap up. Let's do a negative fraction in front. So we'll do this negative 1/3. We do the x plus 6 times x plus 6 as the first thing. So we get negative 1/3. We'll just hold on to that. Then we have x squared plus 12x plus 36. And you don't have to go straight to that. You can still write out the area model. You can still draw the distribution arrows, whatever you need to do in order to create that. Eventually, you want to get to the point where a plus b squared, you basically just shortcut it to a squared plus 2ab plus b squared. But we're not quite there yet, so if you can't do that, that's okay. Likewise, a minus b squared, we eventually want to just think of a squared minus 2ab plus b squared and not need to do those middle steps. But doing them right now, showing the area model or showing distribution, will really help us not to lose this 2ab in the middle. That's the biggest problem, is we lose that if we just try to distribute the exponent separately to a and b. Okay, I still have my minus 1 here as well. So now we're going to distribute the minus 1/3. We get minus 1/3 x squared minus 4x minus 12 minus 1. So my final answer to this one is y equals negative 1/3 x squared minus 4x and then minus 13. So hopefully this is pretty straightforward and just a review of stuff that we've done before, but that is the process for converting from vertex form into standard form.